Hello guys, Midas back again with another video, and today we'll be looking at the Project Euler project. So like I said in the previous video or the intro of the series, I said we'll be going through uh, the problems on Project Euler. The reason we'll be doing that is we'll be solving the problems on that website, and I'll be showing you how I normally go through solving a problem. So the steps I take into solving a problem, and then optimizing, refactoring the code to make it more efficient or to make the code cleaner. So my process normally I just look at the problem, try to understand it, and then try to solve it in as quickly as possible. And then after that, I then start cleaning the code and trying to make it optimal. So the most important thing is normally to solve the problem, and then we can look at other things afterwards. So, or a different approach. Sometimes you get it the first time, the optimal solution, but other times you don't. So you go back to the drawing board, see where you how you can tweak your code and things like that. So I'll be going through those steps today. So let's see what problem we have for today. So head over to the Project Euler website. So the URL is projecteuler.net. So let me just start over. So when you first get onto the website, that's what the website looks like, and then we'll be going through the archive. So I'm just gonna zoom in a bit. So yeah, we'll be going through the archive, and the archive section we'll be going through the problems one by one, each and every day, learning different type of things as we go. So problem one today, we have multiples of 3 and 5. So this is what I kind of like showed you this in the introduction video yesterday. But today we'll actually be solving this problem. The problem states, if we list all the natural numbers below 10 that are multiples of 3 or 5, we get 3, 5, 6, and 9. The sum of these numbers is 23. Find the sum of all the multiples of 3 or 5 below 1,000. So let's I'm just gonna copy this guy so that we can have this in our code. So I actually haven't showed you the multi-line comment. So I've showed you the single line comment where you do that, and if you wanted to comment on a different line, you do that and add a different line. But it can actually add a multi-line comment. So if you're using VS Code like we installed in the previous series on Technanimals, so what you can do is / hold the shift button, press 8 on your keyboard twice, and then you get something like that. And then once you have that, you can actually just press enter and you can comment. So you can just write everywhere here. So this is a multi-line comment. So that way, so what I want to do, the purpose for this is so I can actually paste the problem over there. So we can work with the problem in our code. So there. So yeah. So I'm just gonna have it there. So now we have the problem in our code. So if we list all the natural numbers below 10 that are multiples of 5 or 3, we get whatever. So now at least we have the problem here, so we don't have to go back and forth and try to understand the problem again, because we'll have the problem in our code. So what we need to do is first, so if you look at this problem here, they told you something here. The sum of these multiples is 23 when you look at the ones below 10. So we can actually, after having written our solution, we can actually use this as our test case. And then you can try to gauge if obviously your test case is wrong, that means your solution is wrong. And then after that, get an answer for numbers below 1,000. And we'll actually, so you you can create an account on this website. So I'm just gonna create an account quickly, so we can be able to submit our answers here to see if our problems are actually correct. We have, now that we've created an account and logged into the site, you can actually, now when you click on the problem, you can actually put your answer there, so you can actually confirm our answer when we're done. So let's move over to the code. Looking at the problem, we can see that we have to do multiple things. So first we need to get the multiples of 3 and 5, and then after that we have to get the sum of those multiples below 1,000. So now what do we need to do to evaluate numbers below a certain point? So we learned about the for loop in my previous series. If you don't know what the for loop is, just look at the video in the top right section of this video, and then you can come back and try to continue the lesson with us. So let me create a function. So I'll call the function called sum multiples, right? Multiples. And then our sum multiples function should take in the limit. So here they started with the limit for 23, and then here they evaluated the code with the limit for 1,000. So we'll take in our limit as an input, and then which is of type number. So what do we want to do with the limit? So we want to loop go through all numbers below 1,000 and check if they are then any number in that range is a multiple of 3 or 5. So we write our for loop. So for let I equals to, now we just started coding and we didn't actually try to let's define a few things. So a multiple, if something is a multiple of another, that means that number is divisible by that other number. So if 15 is divisible by 3, that means when you divide 15 by 3, there isn't any remainder, right? So, and we actually don't include 1. So everything, when you divide everything by 1, it remains that particular number. So 1 does not count as a multiple of any number. So that means we can actually start off our loop at 2, right? And then when do we stop our loop? We stop our loop at the limit, before the limit, right? And then the I plus plus, so our loop is not infinite. So yeah. So now what do we need to do in this case? We need to check if the number I is a multiple of 3 or 5. So how do we do that? We learned about the mod function in the previous series, the Typescript essential series, where we use the percentage sign to check if something's actually divisible by another one. So we have here, if I is a multiple of 3, right? That means if I is divisible by 3, which means the remainder of I divided by 3 is 0, right? And then we also learned about our Boolean operators, which is now we need to, here they said 3 or 5. So if something is a multiple of 3 or 5, so we also need to check if it's also a multiple of 5. And the Boolean operator, we use the OR operator, and we also need to check if that's a multiple of 5 as well. So if that's the case, if that's 0 as well, then what do we need to do? We need to sum those numbers that satisfy this condition. So that means we need to keep some form of a count of a we need to store our sum in some variable so that we can add to it. So now we start off our sum at 0 outside of the loop, and then what we do, sum is equal to sum plus I. So now this should actually give us a solution. Then we can actually just return that number back to the sum back to us after we've added things to it. So now let's see if this actually works. So now we want to, let's just console.log some multiples of. Let's start off with our test case. So our test case here is numbers below 10. So we start off with 10 and we expect the answer to be 23. So yeah. So before, like in the previous video, I was showing you how we compile and then run the code. There's actually this other tool that I use. It's called TS Node. So you can go ahead and install it. So you can go npm install TS Node global. Just copy down that command and then press enter, and then you should have TS Node on your computer, so that you don't have to compile and run your code all the time. So you can actually just run it without compiling it. So we'll use TS Node. After installing that, you should have this command onto your terminal. So you can actually now just run the code like that, and you should actually get the answer. So looking at that, you can see that we have the answer 23. That means that our solution is the correct one. Maybe you think maybe it works, but now let's test it on the actual question. The question says numbers below 1,000. So if we go ahead there and make it 1,000, let's see if this is actually correct. So we can go all back onto the project Euler website and then save it there. Type in the confirmation code. And then check if your answer is correct. It's taking quite a bit to load. I'm gonna go ahead and just try and reload. See, because yeah, so it actually was a correct answer. I don't know why was taking so long to load, because that's, yeah, I don't know why. But if you go back to the archive, you should, if you look at the first problem, you can see there's a little green tick over there, which means that you actually got the right answer. So meaning that our solution was actually the correct solution. So now that we've solved the problem, we can go back to our function and see if there's anything to improve, right? Now looking at this solution, we can try and see if there's anything that we can improve on. But I don't think I can see anything. If you guys see something we can improve on, maybe it's something mathematical that I don't know about that can actually make our code more efficient. But at this point, I do not see anything we can improve on. So yeah. So see you in the next video. Tomorrow we'll be looking at the next problem, which is the even Fibonacci numbers. We'll get to see what the Fibonacci numbers are, and then we'll try and solve this problem. So see you in the next video. Yes, sir.